Hi, welcome back. So in the last video we have started 2D stress problem. So now in this video we are proceeding to the next second problem on the 2D stress problem. So the problem is determine the stress distribution and place displacement for a rectangular plate with a hole at the center plate with an uniform thickness of 10 mm. A uniform pressure of P is 100 megapascal acting on the boundary of the hole as shown figure. Assume Young's modulus is 120 GPa and Poisson ratio is 0.28. Assume plane stress condition. So now this is a figure they given. This is a plate. Again there is a hole. Plate dimension is 400 by 200, and at the center the hole diameter is 150. Now what is the difference between the previous and this problem is here they are applied the pressure on the outside of the plate, but now the pressure is applied inside a hole. It means this is known as internal pressure. That is known as external pressure. So that is the main difference. And rest of things are as usual. We need to find the stress and displacement. So let's get into the Ansys window to solve this problem. Now go to preference structural. Okay. Preprocessor element type add solid. Okay. Then options we need to give a thickness. Okay. Then close it. Real constant add okay, then thickness of this plate will be around 10 mm. Now close it. General model, material model, structural, linear, elastic, isotropic, then Young's model's value, that is 120 GPa converted into mm. Your difference 120 into e power 3 and 0. Now it is not 0.3. They are given in the problem. It's a Poisson ratio, right? Therefore 0.28. That value only need to give. Now close this window. Now we go for model. As usual we are going to create a area now. So here also we are going to take up the half quadrant, that is here 200 and this is 200 by 200. Now area rectangle by 2 corner 0 0 200 100. Then we need to create a circle, solid circle 0 0. The radius of the solid circle will become 750 divided by 2, that is 75. So now okay, we need to create a whole mess of, as usual, boolean operation we need to do. So that is we have to operate in that subtract area. First we need to select the rectangle area, press apply. In that whole area we need to subtract. Now this is modeling is done. Now we need to do a FEM element, means for that we need to do a meshing up operation, that is mesh tool. Then keep this smart size on and keep it on 2. Go to mesh, select this area, press OK. So now we got a finer mesh. Now we need to apply a boundary condition. Apply define loads. Now structural. In the problem they are not mentioned that is fixed. So but if you are not fixed you will not get a answer. Therefore we need to fix it as usual. Symmetric boundary condition we need to give. So therefore displacement on lines symmetric as usual we need to apply. Now we need to apply pressure on lines. We need to select the internal edges of the wall, press OK. Now what is the value we need to give? So we are applying a internal pressure of 10 MPa. With respect to wall it is compressive, therefore we need to give 10 megapascal only, that is in Newton per Pascal. Therefore positive 10. If it external then minus. So that means by this we completed the pre-processing part. Let me solve this and we'll check the results. So solution is done. go for general postprocessor nodal solution, then we can go for deformation vector. Now 0.03 mm, so 0.036 mm. And what is the stress value? Go to element stress and one misses stress. Press OK. So that is 50.36. Same thing. So that means we got the same 50.33, that is here. So that means we got the same result, it is validated. So therefore our problem is right. I hope you are all understood this 2D type of problem. By this we complete the 2D type of plane stress problems. So thank you.